Alright, hello guys, my name is Lazaro, and today we're going to be doing a medium LeetCode problem that is called minimum number of days to make m bouquets. Right, so we are given an integer array called bloom day, and we're also given an integer m and an integer k. We need to make m bouquets. To make a bouquet, you need to use k adjacent flowers from the garden. The garden consists of n flowers. The ith flower will bloom in the bloom day of I, and then can be used in exactly one bouquet. Return the minimum number of days you need to wait to be able to make m bouquets from the garden. If it is impossible to make m bouquets, return -1. Right, let's look at a couple of examples. So right here, in example number 1, we're given the integer array called bloom day. Each and every index position of this array is basically a flower. And what these numbers represent is how many days it takes for that flower to bloom. We want to make 3 bouquets, and each bouquet consists of only 1 flower. So here they do a pretty good job of explaining this. On the first day, only this flower right here blooms, and that's the only one we can use on the first day. But let's say we wait 3 days. If we wait 3 days, we can use the first one. We can also use the second one because this one bloomed on the second day. And since it's a 3rd day, this flower had bloomed already. So with each of these flowers, we can make our bouquet of size 3. So now something else to consider is if it's impossible to make m amount of bouquets with k amount of flowers. Here they want 3 bouquets, and each bouquet consists of 2 flowers. So what this means is, if we're on day 10, then every single flower here would have bloomed. But if we try to make 3 bouquets, we get 1 in 10, so that works. Then we get 3 in 10, that's the second bouquet. And now we only have 2. We only have 1 flower when we need 2 to make that 3rd bouquet. In this case, we use return -1. Something else to keep in mind is that they need to be adjacent, as they said right here. Adjacent flowers from the garden. So right here on the 7th day, every single one of these 7s, since they represent a flower and it's the 7th day, they would have been bloomed, and we can actually use them. But we can't create 2 bouquets on day 7. Because they need to be adjacent to each other. We can make 1 bouquet right here, and since we also can repeat flowers, we will need to get another 3 flowers to make the 2nd bouquet. But this flower here, since on the 7th day it would have been bloomed, and these 2 as well, they're not next to each other. As you see, there's a flower between them. So we cannot get them. Right here, they're representing X's with the flowers that have bloomed, and underscores with the flowers that haven't bloomed. So these 3 are next to each other, and we can choose them for the first bouquet. But these 3, they're not all next to each other. Instead, what we have to do, we have to return 12, which is the minimum amount of days that we would have to wait. That way, we can create 1 bouquet like this, and then the 2nd bouquet like that. Or like this. Either way, it doesn't matter. All right, so now that we went over everything, we went over the description of the problem and a couple of examples, we have a rough idea of how to do this. Let's actually get into the intuition behind it. So at first, this problem might seem a little bit tough, but it's actually way easier than you think. So right here, these are how many days it takes for this flower to bloom. Let me write their index in the bottom. That might help a little bit. There we go. So at index 0, this is a flower, this is a flower, this is a flower, this is a flower, and this is also a flower. Now, this flower right here takes 1 day to bloom. This flower right here takes 10 days to bloom. This is what the array does. This is what this bloom day array means. And it's very important to know that. Now, how can we find the minimum day where we can make m bouquets with k flowers? Well, First, what we can think of is what is the minimum amount of days we need for a flower to bloom inside our given array? Right here we can see it's 1. So let's write that down. Now let's consider how many days the maximum amount of days it takes for the last flower to bloom, or the maximum amount of days it takes a flower to bloom. There we go. That's better wording. So the minimum is 1, and then the maximum is 10. So our minimum amount of days to make M bouquets with K flowers is somewhere between 1 and 10. Let's write down every single number between these. 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then 10, of course. That 10 is a little bit too far away from the 9. Let me just fix that. There we go. Now it looks ugly. Okay. So anyways, these represents the amount of days we can choose, ranging from the minimum amount of days for a flower to bloom in the array to the maximum amount of days it takes for a flower to bloom in the array. Our answer is somewhere in here. Now, what we can do is we can go over each and every single day and then check if we can make M bouquets with K flowers. So on the first day, this bloom day array, or the flowers that have bloomed, would have looked like this. This first one would have bloomed, so that's an X. This second one would not have bloomed, underscore. The third one would not have bloomed, underscore. Nor the fourth or fifth. So it will look like this. Now, if we iterate over this new array and check if we can get 3 bouquets, each having 1 flower, we will find that the maximum bouquets we can make is just 1. Let me write it like this. Oops. Bouquets equals 1. If we are on day 1. So since the maximum amount of bouquets we can make on day 1 does not equal 3, we know that we have to go 1 more day. Let's see what we can do with the second day. On the second day, this array turns into X underscore 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 X. Because on the second day, this first flower would have bloomed, and so would have this one. Here, the maximum amount of bouquets we can make is now equal to, instead of 1, it's equal to 2. But 2 still does not equal 3. So we have to go 1 more day. If we go 1 more day, we're on the 3rd day right now. This array becomes X underscore X underscore X. Now on the 3rd day, we could make 3 bouquets, which is equal to the M amount of bouquets that they're asking for. Therefore, 3 is the minimum amount of days we can choose. But there's a problem with this. We're iterating through all of these possible amount of days in a for loop fashion. For every single day we stop on, we also have to use another for loop to compute how many bouquets we can make on that day. So that right there is 2 for loops, which leads to big O of n squared. But there's a better way of doing this. Instead of iterating through the possible amount of days in a for loop fashion, if we use binary search, we can bring down this time complexity to big O of n log n with constant space complexity. So this is not, n squared is pretty bad, but this is slightly better, way better actually. So we're gonna go with that approach. Let me give myself some more room. There we go. Then let me scroll down. So how can we use binary search to solve this problem? Well, before I get into that, let's first talk about something else. Let's talk about when it's impossible to actually solve this question. It's impossible to solve the question when they're asking for m amount of bouquets with k flowers when there's not enough flowers to make m amount of bouquets with k flowers. As you can see right here, they want 3 bouquets, and each bouquet takes 2 flowers. So 3 times 2 is equal to 6. That's how many flowers we need. But the size of the array, it only has 5 flowers. Therefore, we know it's going to be impossible to solve this question with only 5 problems. So that's a little check we want to do in the beginning of the question. So let's write that down. How would that look like? Well, if we take bloom day, if you, in this case you guys forgot, let me also write down. Let me write down how the example problem looked like. Whoops. So bloom day is our integer array, which represents a flower, and the flower at the ith position represents how many days it takes for that flower to bloom. And then m is equal to the amount of bouquets they want, and k is equal to the amount of flowers they want for each bouquet. Great. So let's do that check we talked about. So if the length of bloom day if it's less than m times k, the number of bouquets times the flower bouquet, the amount of flowers per bouquet, if it's less than that, then we want to return -1, because it will be impossible to solve this problem. Let me rewrite this if, because it doesn't really look much of an if. Great. Now, we already know we're going to be using binary search to find the minimum amount of days to make m bouquets with k flowers each. We know we're going to be using binary search, but let's first work on the method of, or work on a function that's going to tell us if we can make enough bouquets that's greater than or equal to m with the current day we're on. So right here, I'm just going to write function, so you guys know it's a function. And I'm going to call it make bouquet. And it's going to take days as an argument. Inside of this function, we want to keep track of 2 things: the amount of bouquets that we can currently make on this day, and the amount of flowers that have bloomed. So let's write those 2 variables. So right here we have bouquet count, and we're going to initialize it to 0. And now we're also going to have our bloom count, which shall also be initialized to 0. Now keep in mind, guys, this is just pseudocode, but it should be simple enough for you to transfer over to your preferred language. Now we're going to be creating a for loop. This for loop is going to be going over our bloom day array and keeping track of how many flowers have bloomed on that day. So for flower in bloom day, if that flower is less than or equal to the current, I should be renaming this, except days should be called day. Sorry about that. Let me just change it to day. All right. So if this flower is less than or equal to day, oh, you know what? Days actually works because it could be more than just one. So yeah, let's change it back to days. So if this flower is less than or equal to days, then we know it has bloomed. And if it has bloomed, we want to increment our bloom count. Plus, or equals, plus equals, I'll do plus equals 1. If this is not the case, if it is instead, it takes the flower longer, more days than the one we passed in, then we want to set bloom count back to 0. And the reason we're doing that is we're basically checking if there's a flower that is not adjacent and it hasn't bloomed, let's just restart. Because that's something to keep in mind, that each and every single flower that has bloomed, for it to be part of a bouquet, they all have to be adjacent to each other and cannot be reused. So let's write that else condition. Else bloom count is equal to 0. So now we're keeping track of how many flowers has bloomed. But let's say we have enough flowers that have bloomed that could be part of our bouquet. We know that it can be part of our bouquet if the bloom count, if it's greater than or equal to k. Since each bouquet takes k amount of flowers, that's why we're comparing it to k. We want to see if we have enough flowers to finally make one bouquet. If that's the case, then let's reset bloom count to 0, and let's increase or increment bouquet count. Perfect. And that's our whole for loop. Once we get out of this for loop, there's one more check we want to do. What we want to return is going to be a boolean. If we have enough bouquets that's greater than or equal to m, then we return true. If not, we return false. So instead of breaking this up into an if and else, we can just return bouquet count is greater than or equal to m, where m is the amount of bouquets we want to make. So let's say we passed in 3 into our function, 3 days into our function. From there, we will go over each and every single element, and we know this one has bloomed, this one has bloomed, and then this one has bloomed. Since k is just 1, we just need to check if there's only one flower. We don't want 2 adjacent flowers because k is now 2. In that case, we will increment bouquet count once here, and then once here. And then finally, in this function, we'll be returning that our bouquet count will be returning true because our bouquet count is greater than or equal to m. So that's what that function is doing. So this is the function, whether we're doing a for loop approach or binary search, that we will 100% need. Now let's scroll down and then actually do the binary search. Our left pointer is going to be equal to the minimum amount of days inside bloom count. Inside bloom day, which is our array. Our right pointer is going to be equal to the max amount of days it takes for a flower to bloom inside our array called bloom day. Now that we have our left and right pointer, we can start our while loop. So while left is less than our right, then inside here we compute our mid, which is just left plus right divided by 2. And now we want to check if this mid value, which mid is going to be a day, is be a day between the minimum amount of days and the maximum amount of days. We want to check if that mid, how many bouquets can it make? If this day, let's say mid is equal to 5 days, can we make enough bouquets that is greater than or equal to m? To do that, we just pass it to our function. Let's also keep track of it inside a variable called canMake. Let me see, what did I call this function? I called it makeBouquet. All right. So we're going to call that function makeBouquet. Did I add an S or did I not? I did not. Okay. And then we pass mid, which is our day. So if this comes back true, if canMake, then we want to set our right pointer to mid. The reason we're doing that is, if we go up here, let's say this was mid. Our right pointer is right here, our left pointer is right here, and then our mid is 3. If this comes back true, then we can change our right pointer to where mid is. And then that way, we can check, oh, actually this is gonna be wrong, I'm sorry about that, guys. I shouldn't be doing it on this array, I should be doing it on this array up here. This is our left pointer right here, there we go. And then our right is gonna be right here. And let's say our mid is 5. If this comes back true, then we're gonna be moving our right pointer to where the mid is. And then we're gonna be checking all these other values to see if there's a value that's less than 5. Because we want the minimum amount of days. So we're kind of breaking it down, and now we're checking between 1 and 5, which will give us 3, and then see if that comes back true. Perfect. Now let's continue. So if that comes back true, our right pointers be equal to mid. Else, our left pointer, this should be a capital. There we go. And our left pointer is going to be equal to mid plus 1. And the reason we're doing plus 1 is, let's say 5 came back false. We know 5 is already out. So there's no reason to set left equal to mid. Instead, let's just set left equal to 6 and try that. The reason why we didn't do it for right, why instead of doing right is equal to mid minus 1, is because once our right is on top of a possible value, possible value, our left is eventually going to fall on top of that. And the reason we want that is because outside of this while loop, what we're going to be returning is our left pointer. Because our left pointer should have stopped on the minimum amount of days it takes to make n bouquets with k flowers. And that's the whole code, as you can see right here. So all of this. Now let's actually write the code out. Whoops. Oh, all right, perfect. All right, so let's first do our check. If the length of bloom day, if it's less than m times k, then we know it's impossible to solve this question with how many flowers we were given. So let's just return -1. Then let's create our function. Let's call it make bouquets, or bouquets, yeah. And then let's pass days as an argument. And now we want to create our 2 variables, bouquet count and bloom count. Bouquet count, set it equal to 0. Then we do the same thing, but this time with how many flowers have bloom, call it bloom count. Now let's iterate over bloom day and see how many flowers have bloomed, and if we have enough flowers that have bloomed, let's try to make a bouquet out of it. So for flower in bloom day, if flower is less than or equal to days, then we know it has bloomed. So let's increment bloom count. Else, if this is not the case, then what we want to do is set bloom count to 0 because it's not adjacent. And since the problem asks for only adjacent flowers, that's how we treat this. Now, if our bloom count is greater than or equal to k, then we reset bloom count to 0. There we go. We reset it to 0, and then we increment bouquet count. And now we're done with this for loop. But of course, we need to return if bouquet count is greater than or equal to m. Now let's actually start getting into our binary search. The left is going to be equal to the minimum inside of bloom day, like we talked about. And then the right is going to be equal to the max. Then let's get our while loop. So while left is less than right, let's compute our mid, which is just equal to left plus right divided by 2. I'm doing slash because in Python, this is basically interdivision. Now let's create our variable called canMake, call our function, and then pass in mid, because mid is basically a day that we're testing out. So if we can actually make m amount of bouquets on this mid day, then what we want to do is set our right pointer to mid, else let's set our left pointer to mid plus 1, because we know this day didn't work, so let's just increment it by 1. And then we can just return left. Alright, so let's run the code and see if this works. Alright, it works here. Now let's submit it. Alright, and it works. Perfect. So I hope you guys enjoyed the video. If you did, then please make sure to join our Discord. This will be linked down below in the description, where we send out not only beginner problems but advanced problems as well. Right? So yeah, hopefully you guys enjoyed and have a nice day.